Good morning, students. Myself, Dr. Premati Akkasariga, working as professor and PG coordinator in the Department of Computer Science, BLEAS, Vachana Pitamaha, Dr. PG Halkatti College of Engineering and Technology, Vijaypur. Today I am going to discuss about memory allocation techniques. Now we'll discuss about contiguous memory allocations. The main memory must accommodate both the operating system and the various user processes. We therefore need to allocate main memory in the most efficient way possible. The memory is usually divided into two partitions, one for resident operating system and one for user processes. We can place the operating system either in low memory or in high memory. Since interrupt vector is often kept in low memory, programmer usually places the operating system in low memory only. Each process is contained in a single contiguous section of the memory in contiguous allocation technique. The issue of memory mapping and protection provided using relocation register as discussed in 8.1.3 together with the limit register discussed in 8.1.1. The relocation register, which is known as base register, contains the value of smallest physical address. The limit register contains the range of logical addresses. With relocation and limit registers, each logical address must be less than limit register. The MMU maps the logical address dynamically by adding the value in the relocation register. This mapped address is sent to the memory as shown in the figure in the next slide. The figure shows the hardware support for relocation register and limit registers. To generate the physical address for a process in the memory, the logical address must be less than the limit register. Then to that it adds relocation register contents to generate the physical address. Now we'll discuss about multiple partition allocation methods. One of the simplest methods for allocating memory is to divide memory into several fixed sized partitions. Each partition may contain exactly one process. Thus, the degree of multiprogramming is bound by number of partitions. And the method is known as multiple partition fixed size allocation method. We have one more method of variable partition scheme. Here, the operating system keeps a table indicating which parts of the memory are available and which are occupied. Initially, all memory is available for user processes and is considered as one large block of available memory, which is known as a whole. Eventually, memory contains set of holes of various sizes. Now in the figure, we have an operating system and the available free space is allocated to three processes, namely process 5, process 8 and process 2, where the memory for process 5 and process 2 is smaller compared with the memory allocated for process 8. So this we can give it as an example for variable partition, multiple partition allocation method. In the next figure, when a process 8 terminates, it releases its block of memory, which is then placed back into set of holes. If the new hole is adjacent to other holes, these adjacent holes are merged to form one larger hole. At this point, the system may need to check whether there are processes waiting for memory and whether this newly freed and recombined memory could satisfy the demands of any of the waiting processes. This procedure is particularly an instance of general dynamic storage allocation problem, which concerns how to satisfy the request of size n. So, as shown in the next part of the same figure, the memory returned by process 8 is allocated to two processes, process number 9 and 10, and we have one small hole left over here. In dynamic storage allocation methods, we have one query: how to satisfy a request of size n from list of free holes. There are three solutions for this, namely first fit method, best fit method, worst fit method. In the first fit method, allocate the first hole that is big enough for the process. Searching can start either at the beginning of the set of holes or at the location where the previous first search ended. We can stop after finding a free hole that is large enough. In the next method, known as best fit, allocate the smallest hole that is big enough. We must search the entire list unless it is ordered by size. This strategy produces the smallest leftover hole. The third method is worst fit. Here, allocate the largest hole to the process. We must search the entire list unless it is sorted by size. It produces largest leftover hole. So normally first fit and best fit are found to be better than worst fit in terms of speed and storage utilization. Now we'll discuss about fragmentation. Fragmentation is the leftover memory during allocation method. There are two types of fragmentation: external fragmentation and internal fragmentation. External fragmentation represents total memory space that exists to satisfy a request, but it is not contiguous. Internal fragmentation is allocated memory may be slightly larger than requested memory. This size difference is memory internal to the partition but not being used. So in all, we can say external fragmentation is the entire contiguous block which is left out after all the processes are being allocated. The internal fragmentation is within every partition. The small holes are created after the process is being allocated to the partition. We can discuss these two methods in my next video using one problem. Thank you all. Stay home, stay safe.